Hey everyone, welcome back. Before we embark on a journey that spans hundreds of millions of years and traverses the vast expanse of our galaxy, I'm sending out massive waves of positive energy and heartfelt wishes to every single one of you watching. Wherever you are in the world, I genuinely hope you're feeling fantastic, taking amazing care of yourselves, and staying healthy, because appreciating the grand scale of the universe starts with cherishing the life right here on our little blue planet. Now, get ready to shift your perspective from our daily lives to a timescale so immense it defies imagination. We often picture the sun as a fixed point with planets circling around it, but here's a cosmic truth that redefines our place in space. Our entire solar system, the sun, Earth, and all the planets, is hurtling around the center of the Milky Way galaxy, completing one full orbit roughly every 225 million years. That's right. While Earth spins daily and orbits the sun yearly, the sun itself is on an epic voyage, carrying us along on a galactic carousel ride so vast that a single lap takes longer than dinosaurs walked the Earth. It's a humbling reminder that we are not just inhabitants of a planet, but passengers on a starship navigating the spiral arms of our cosmic home. So, let's break down this incredible motion. Picture the Milky Way galaxy. From afar, it looks like a colossal, glittering pinwheel spinning in the void, a barred spiral galaxy with billions of stars, vast clouds of gas and dust, and mysterious dark matter holding it all together. Our solar system isn't sitting somewhere special in the center. It's actually located way out in the galactic suburbs, about 27,000 light-years from the bustling core. Think of the Milky Way as a gigantic city. The galactic center is the dense, bright downtown, and we're orbiting in a quieter residential district, roughly 2/3 of the way out towards the edge. Just like Earth orbits the sun due to the sun's gravity, the sun, and everything bound to it by gravity, including us, orbits the immense gravitational center of the Milky Way galaxy. This center is dominated by a supermassive black hole called Sagittarius A, pronounced Sagittarius A star, which has a mass millions of times greater than our sun. While the black hole itself is tiny, the combined gravity of all the stars, gas, dust, and especially the huge halo of invisible dark matter concentrated towards the center creates the powerful gravitational well that keeps our sun, and hundreds of billions of other stars, whirling around it on their own paths. The sheer scale of this orbit is mind-boggling. That figure, 225 million years for one complete trip, is often called a cosmic year or a galactic year. To grasp how long that truly is, consider life on Earth. The last time our solar system was in this particular spot in the Milky Way, the Triassic period was just beginning. Dinosaurs were emerging as the dominant land animals. The supercontinent Pangaea was still mostly intact. Flowering plants hadn't even evolved yet. Mammals were tiny, shrew-like creatures scurrying in the shadows. A single galactic orbit encompasses the entire reign of the dinosaurs, their catastrophic extinction, the rise of mammals, the evolution of primates, and the entire blink-of-an-eye history of humanity. All of recorded human civilization, from the first cities to the internet age, fits into less than 1,000th of the time it takes to complete one galactic lap. It's a timescale that connects us directly to the deepest past of our planet. How fast are we moving on this galactic journey? Hold on to your hats, because the speed is absolutely staggering. Our solar system is racing through space at approximately 514,000 miles per hour, roughly 828,000 kilometers per hour, relative to the galactic center. That's about 143 miles every single second. To put that into perspective, it's fast enough to travel from Earth to the Moon in less than 30 minutes. Yet, despite this incredible velocity, we feel absolutely nothing. Why? Because everything around us in our local region of space, the sun, the other stars in our neighborhood, is moving along with us at roughly the same speed and direction. There's no bumpy road or sudden turns. It's a smooth, constant cruise through the vast emptiness of interstellar space. We only perceive our motion relative to closer objects like other planets or the sun. The galactic motion is so constant and the distances so vast that we're completely unaware of this high-speed galactic voyage in our daily lives. It's the ultimate smooth ride. You might wonder, how do astronomers even know this? How can they measure such an immense orbit? It's a brilliant combination of precise observation, understanding gravity, and mapping our galactic neighborhood. A key method involves carefully tracking the motions of stars relative to our sun. Astronomers measure the proper motions of nearby stars, their tiny apparent shifts across the sky over decades, and their radial velocities, how fast they are moving towards or away from us, measured by the Doppler shift in their light. By compiling these measurements for thousands of stars, especially those in the direction of the galactic center, towards the constellation Sagittarius, scientists can work backwards. They can figure out the motion our own sun must have relative to the average motion of these surrounding stars to create the patterns we observe. It's like being on a moving train and watching the scenery outside. By seeing how other objects, stars, appear to move, you can deduce your own train's, the sun's, speed and direction. Knowing our approximate distance to the galactic center, measured using variable stars called Cepheids as standard candles, and our speed, physicists can then calculate the orbital period using the laws of gravity and circular motion. While the orbit isn't a perfect circle, it's slightly elliptical and bobs up and down through the galactic plane. 225 million years is the well-established average time for one revolution. Our path around the galaxy isn't a simple flat circle. Imagine the Milky Way's disk as a slightly warped vinyl record. Our solar system doesn't orbit perfectly within the plane of this disk. Instead, it bobs up and down as it travels around the center, much like a carousel horse that also moves vertically on its pole. It takes about 60 to 70 million years for the Sun and us to complete one full vertical oscillation, moving above the galactic plane, dipping below it, and returning. Some scientists have speculated whether these periodic dips into denser regions of the galactic disk, which might have higher concentrations of interstellar gas, dust, and potentially disruptive gravitational perturbations, could have influenced Earth's history. Could passing through a denser spiral arm or a molecular cloud increase comet activity in the Oort cloud, potentially leading to more impacts on Earth? Could it subtly affect the solar system's environment? While there's no definitive proof linking the galactic bobbing directly to specific mass extinctions like the dinosaur-killing Chicxulub impact, it's a fascinating area of research, reminding us that our cosmic environment might play a role in events on Earth over tens of millions of years. Speaking of spiral arms, our orbit takes us weaving in and out of these grand structures. The Milky Way's magnificent spiral arms aren't rigid lanes of stars like cars on a highway. They are more like density waves, patterns of compressed gas and dust that move through the galaxy at a different speed than the individual stars. Think of it like a traffic jam moving along a freeway. The jam itself, the spiral arm, propagates at one speed, while individual cars, stars, enter it, move slower within it, and eventually exit it, continuing at their own pace. As our solar system orbits, it periodically enters and exits these spiral arms. Passing through an arm means encountering a region with a higher density of interstellar material, more star-forming regions, and potentially stronger gravitational tides. While this passage doesn't drastically alter our stable orbit around the Sun, it does change the stellar neighborhood we travel through and the view from Earth over millions of years. What does the future hold for our galactic journey? The Milky Way is not a static island. In about 4.5 billion years, our galaxy is set for a monumental collision with our nearest large neighbor, the Andromeda Galaxy, M31. This merger will dramatically reshape both galaxies, scrambling stars and orbits. However, during the long approach and the actual collision, which will take hundreds of millions of years itself, our solar system will continue its orbit around the Milky Way's center. By the time the merger is in full swing, we will have completed roughly 20 more orbits, 20 galactic years, since the formation of the solar system. The merger will likely fling our solar system into a new, wider orbit within the resulting merged galaxy, often nicknamed Milkdromeda. But the fundamental motion, orbiting a galactic center, will continue, albeit within a transformed stellar metropolis. Throughout this, the Sun itself has a limited lifespan. In about 5 billion years, it will exhaust its core hydrogen, swell into a red giant, and eventually shed its outer layers, leaving behind a cooling white dwarf. Long before the Milky Way Andromeda merger is complete, our Sun will have ended its main sequence life, but the remnants of our solar system will likely continue their journey around the galactic center for many billions of years more. Understanding this grand orbit fundamentally changes our perspective. It shatters the illusion that our solar system is stationary or central. We are in constant motion, part of a vast, dynamic flow of stars tracing paths around a distant gravitational anchor. That 225 million-year galactic year is a cosmic metronome, ticking off chapters in Earth's deep history far longer than any human timescale. It connects the emergence of life to the structure of the galaxy itself. It reminds us that we are stardust not just in composition, but in motion, hurtling through the void on a path set billions of years ago. The stability of this orbit, governed by the gravitational symphony of stars, gas, and dark matter, has provided the long-term cosmic environment necessary for the slow evolution of life on Earth. Contemplating the galactic year fosters a profound sense of humility and awe. We are fleeting observers on a small planet, witnessing less than 1,000% of a single galactic orbit. Yet, within that blink of cosmic time, we have developed the intelligence and technology to map our trajectory through the Milky Way, to comprehend the vastness of our journey, and to wonder about our place within it. So, the next time you look up at the Milky Way stretching across the night sky, remember, you're not just looking out into the galaxy, you're seeing the path we're traveling. You are aboard a starship on a 250 million-year loop around the heart of our galactic home, a journey begun long before life arose and continuing long after we are gone. It's the grandest voyage imaginable, and we're all along for the ride. Thanks for contemplating the galactic year with me today. Stay curious, stay healthy, and keep looking up at the spiral path we travel.